Hello, my name is Sophie Baker, and this is a pre-recorded presentation for the 2020 International Conference on Cognitive Modelling. And I'd like to talk to you about decision-making as a closed-loop process. So that's me in the top left corner. Welcome to my poster. So most work and theory on decision-making is based on physically restricted, decide then act, open-loop tasks. However, we're fundamentally embodied, and so decide while acting is more ecologically valid, where decision-making is closed loop. Some embodied decision theory has been developed, however, there's more to do. Specifically, we're interested in the form and dependencies of velocity during embodied decision-making and the neural implications of embodied decision-making with respect to stabilizing the decision and with respect to how embodiment affects the process of evidence accumulation and affects stability of the decision. We built on the model by Lepora and Pizzullo, outlined here, which accounts for movement trajectories but not for velocity profiles, nor does it fully explore the effect of embodiment on neural gain or bias. So these are some really interesting ways in which the model can be extended and which have some really interesting implications, which we'll see in a second. So what data are we using to develop the model and some context? We use data from a two-alternative force-choice task, tracking computer mouse movement. There are some challenges with this due to the volatility of mouse trajectories and the implicitness of evidence accumulation in this task. Some context. So velocity and confidence have found to be related in act-while deciding tasks, and that there is indeed some form of bias and evidence accumulation in these types of tasks. Additionally, there's some work indicating that active behavior stabilizes neural activity, resolving uncertainty by acting. Focusing just on models of velocity, there's a vast space of both neural and behavioral variables on which velocity could reasonably depend, but the parameterizations for these variables is extensive too, while all being reasonably sensible. And this gives us this very, very broad model space, and this is just for velocity. The same is true for the evidence accumulation gain model, with the additional consideration of neural activation. So how these values for evidence accumulation are held in mind, and how that concept of held in mind is affected by action. This work has some really interesting implications. Firstly, that action not only modifies but stabilizes the decision by literally reducing the variance of neural populations implementing choice. Secondly, that there is a fundamental difference in the way the brain implements embodied versus classical physically restrained choice. And finally, how embodiment affects the sustained activation of neural populations implementing choice that have been measured in classical decision-making tasks. So I've opened up the question of decision-making as a closed-loop process, and we have some next steps. So data analysis to constrain and compare our models, model development, so velocity and gain models. From these, we'll look for insights with respect to those implications outlined above. And then we look to the question of optimality. So what is embodied decision-making optimized for? For example, how these interact with physical cost functions and restrictions. So we look forward to sharing more of this work with you as it develops. Thank you very much for listening.